early scientists of Greece and Rome were called alchemists, and their primary purpose was to find the philosopher's stone, a stone that was rumored to turn any metal into pure gold. It produced the elixir of life. This elixir could give the drinker strength and immortality. Thank goodness that because of the alchemist's fear of dying, we have some of the most popular franchises and careers for 11-year-olds. In 460 BC, in ancient Greece, an alchemist called Democritus studied plants, rocks, and other metals. He theorized that if you take an object, something as whole as an apple, and then you cut it in half, and you continue doing this, cutting it in half again and again and again, until you would end up with particles so small they couldn't be divided anymore. These particles were made of whatever the original object was: fire, air, water, plant, or earth, even animals. He said that these particles fill up space completely and are tightly packed. He called these objects atomos, meaning indivisible. Another philosopher of ancient Greece was called Aristotle. He had a lot of followers in the scientific community, and he argued that the idea of atoms was false. So the idea of atoms was trashed for hundreds of years. In 1777 in France, where there probably wasn't an Eiffel Tower back then, a scientist called Lavoisier studied how metal and acid react to form hydrogen. He realized that the mass of products is equal to the mass of reactants. In 1803, in England, John Dalton studied the evaporation of water. His discoveries led to his creation of the atomic theory. The first point was that atoms make up everything. All atoms of the same element are equal in size, mass, and other properties. Atoms cannot be broken down, created, or destroyed. Atoms combine in whole number ratios, and during chemical reactions, atoms rearrange. This led to the creation of the law of multiple proportions and the law of definite proportions. In 1869 in Russia, a man named Dmitry Mendeleev arranged elements into groups with similar properties and called it the periodic table of elements. In 1879, Sir William Crookes experimented with a cathode ray, which literally shot out negatively charged particles. In 1895, William Röntgen placed a black film in front of the cathode ray, and the light from the cathode ray still created an image beyond the black film. So he discovered the early X-rays. In 1897, J.J. Thomson included a tightly packed vacuum in the cathode ray because he wanted to elaborate on the idea of negatively charged particles. He used electric plates and a bunch of other complicated science stuff, but he discovered in the end that some particles bounced off negatively charged objects and some went through a positively charged object. With his student Rutherford, they created the new atomic model, with the negatively charged electron sitting right on the atomic ball, the plum pudding model. In 1898, Rutherford carried on with the gold-foiled experiment. Some particles bounced off the gold foil, while others went right through. So in 1911, Rutherford decided that the atom must have empty space. In 1922, Niels Bohr theorized a new atomic model, having the electrons located in multiple shells around the nucleus. He said light and color was created from the atomic energy. In 1927, Heisenberg disproved the idea of the atom being in the solar system because of the principle of indeterminacy. It is impossible to know both the position and velocity of a particle. In 1930, Schrödinger came up with the modern atomic theory of a nucleus made up of protons and neutrons and a crazy electron cloud buzzing around it.